In this video, I will be talking about the fourth learning objective of Chapter 16, comparing probability and non-probability sampling. There are several sampling methods the researcher use, and broadly they are classified into these two categories, the probability and non-probability sampling. So first of all, probability sampling. Probability sampling is a sampling technique where each sampling unit has a known and non-zero probability of being selected. For example, let's say we have 50 students in this class and we want to randomly select 10 from them. So how do you do that? It might be possible that we assign one number to each of the 50 students and then somehow randomly select 10 of them. So that will be an example of a probability sampling, because each of them will have a non-zero and a known probability of being selected. The second one is non-probability sampling. Non-probability sampling is a bit of arbitrary. Here, the sampling units are selected on the basis of judgment or on the basis of convenience. And in this case, it's difficult to estimate the random sampling error. There is no statistical technique of measuring a random sampling error in the case of non-probability sampling. Now we will be discussing different non-probability sampling. First of all is convenience sampling. So from the name you understand that convenience sampling is actually the sampling units are obtained conveniently. For example, you go to a shopping mall, intercept some shoppers, ask questions. You go to a bus stop or a train station and ask questions to people. That will be convenience sampling. And you understand that the main advantage of convenience sampling is it is low cost and you don't need any list of the population. However, the major disadvantage is it can be unrepresentative. Then judgmental sampling or purposive sampling. In this case, sampling units are selected on the basis of judgment or on the basis of the purpose of the study. For example, let's say that McDonald's will go for a test market and the marketing manager selects some major McDonald's outlets to test market a certain new product. That will be purposive sampling. And the advantage is it's moderately costly and useful for certain types of forecasting. However, disadvantage is it can introduce some bias because it's just experts believe that this sample is representative, but actually that might not be. And quota sample is, in this case, the researcher classifies the population by pertinent characteristics and determine the desired proportion of sample from each class, fixes quotas for each interviewer. For example, let's say in your population, there are males and females. So you divide your sample into male and female, and you make a quota that how many males and how many females will be interviewed. Another example can be you have rural and urban people in your sample. So you divide the sample into urban and rural and determine that a certain number of urban and certain number of rural people will be interviewed. Advantages are they are once again moderately costly, and quota sampling is extensively used because it does not require any list of population. However, once again it introduces some bias because of researchers' classification of subjects. And you can see the possible sources of bias when a respondent is chosen by an interviewer. There can be several sources of bias, like similar to interview, easy to found, willingness to be interviewed, middle class. So what do I mean by similar to found? First of all, an interviewer will try to select a respondent which is similar to the interviewer. For example, if an interviewer is a student, well, first of all, will select some students to take part in interview. And also easily found. Interviewers often concentrated their interviewing in areas with heavy pedestrian traffic. For example, downtowns, shopping malls, college campuses. So they find out respondents where they can be easily found. And willingness to be interviewed means like those who interview door to door learn quickly that quota requirements are difficult to meet by interviewing whoever happens to appear, whoever happens to appear at the door. People who are likely to stay at home generally share a less active lifestyle and are less likely to be meaningfully employed. That's why they actually interview the people who are more likely to be interviewed, those who are willing to be interviewed. Another is middle class. Typical interviews actually exclude the lower class from the sample and upper class from the sample, and typically middle class are generally interviewed. This is another sampling technique, snowball sampling. In snowball sampling, the initial sample is selected on a probability basis, and then the next stage sample is selected from the information obtained from the initial sample. Let's take an example that you will be surveying some Australian golf players. Now you know that Australian golf players may not be an easy to access sample. That's why you initially select some respondents on a probability basis, probably from a golf club. And then you obtain information from these respondents about some additional golfers and they interview them. Now, once again, the advantage is low cost. However, it's highly biased because you select the next stage sampling units from the information obtained from the initial sample. So it's very likely that initial sample will provide some information about the next stage sample. Those are likely or those are similar to them. So far we talked about non-probability sampling, now probability sampling. The first probability sampling is simple random sampling. So this is the most widely used and the most typically used in research, that is simple random sampling. In simple random sampling, each sample element has an equal chance of being selected. So what does researcher generally do? Researcher assigns each member of the sampling frame a number, then select the sampling units by random method, maybe by applying a random number generator or so on. But it is costly and it requires that sampling frame to work from. Like you need a very, very defined or very specific sampling frame. The second one is a systematic sampling. In systematic sampling, you select a starting point randomly and then every nth number is selected. For example, you have a sampling frame, you first select a number randomly, it may be 5, 6, 7, 10 or whatever, then you keep selecting like every 5th, every 6th or every 7th or every 9th or every 10th number from the sampling frame. Although it's not purely probability sampling because the next stage sampling or the second stage sampling is not purely random. However, if the first stage sample is selected on a random basis and you have a pretty large sample size, then the result will be very similar to probability sampling. And then stratified sampling. Stratified sampling is pretty much similar to quota sampling, where you divide your population into some strata. For example, as I said, that urban, rural, male, female, or so on. But the main difference between quota sampling and stratified sampling is in quota sampling, each element under a certain quota or under a certain group is selected on a non-probability basis. However, in a stratified sampling, each sampling unit under a certain strata is selected on a random basis. Okay, for example, each male under the male strata or each female under the female strata will be selected on a random basis under a stratified sampling. However, in quota sampling, they will be selected on a non-probability basis. Disadvantage of a stratified sampling is it is costly. However, advantage is it ensures representation of all groups in the sample, and So we also need to remember that it requires accurate information about the strata of the proportion of each stratum. Now, stratified sampling can be two types. One is proportional stratified sampling and non-proportional stratified sampling. In the case of a proportional stratified sampling, what we do is you actually keep the pertinent characteristic of the proportion in the population, you keep this in the sample as well. However, in disproportional stratified sampling is the pertinent characteristic of the population on the basis of the strata was divided, that characteristic is not maintained in the sample. If you look at this example, for example, you are selecting some stores and you have three stratas: warehouse, clubs, chain stores, and small independents. And the population characteristic is there are 20% warehouse clubs, 57% chain stores, and 23% sample independents. Now, in your sample, if this characteristics is maintained, that means in your sample, you have 20% warehouse clubs, 57% chain stores, and 23% small independents. If this is maintained, then it's proportional sample. However, if that is not maintained, for example, 50% warehouse clubs, 38% chain stores, and 12% small independents, if that is not maintained, then it is disproportional sample. Now, we might say that, okay, why this pertinent characteristics is not maintained in a sample? That might not be maintained because of the convenience of the researcher. Okay, for example, if you take like urban and rural people, sometimes the proportion may not be maintained because it might be difficult to interview rural people. So your sample includes more urban people than the rural people. Okay. Another sampling technique is the cluster sampling. In the cluster sampling, you do not select sampling units, rather you actually select a cluster of sampling. Okay, and under each cluster, then you survey each of the elements. For example, instead of selecting sampling units of individual respondents, you select a particular suburb or you select a particular road, and you survey all the respondents in that suburb or all the respondents in that household or all the respondents in that road. So that's cluster sampling. It is less costly and it is frequently used, but large error can arise because you are selecting a cluster that might not be representative of your population. This is the last sampling technique we will be discussing. This is multi-stage area sampling. In multi-stage area sampling, progressively smaller areas are selected in each stage by some combination of the first four techniques. So first four techniques we discussed is a simple, random, systematic, stratified, or cluster. So we actually progressively come to a more smaller sampling unit by any of these techniques. I think there is an example in your textbook. It's exhibit 16.7 that will make this point clear. For example, first of all, let's say we select a particular city. Okay, so a country has 50 cities and we select one city, and from one city we select a particular suburb, and from one suburb we select a particular road, and from one road we select some households, and from some households we select a particular sampling unit. So in this case, you can see that we are geographically getting a more progressively, we are getting a more smaller number of units, from country to city to suburb to road to households, and finally the sampling unit. That is multi-stage area sampling. So this is the end of this video, and we will be discussing the last and fifth learning objective of chapter 16 in the next video. Thank you.